Okay, hi, and thank you for having me. I'm Eyal Gruss. I'm a poet and a new media artist, and I'm also an independent machine learning researcher and freelancer, and I'm trying to combine both fields and also maybe to teach other artists how to use such techniques in their practices. In 1974, Israeli poet David Avidan and prophet, if you want, talked about a day where computer codes with the authors of the transcripts of the future. And we, human beings, we shall be the guiding mind and the approving eye. And I think just very recently, I started to believe that this may be happening now. So in this talk, I want to share with you some of my practices of using AI for art and my thoughts about the interesting recent developments in the field. So I'm not a person of many talents. I'm quite limited. Specifically, I know how to use words and codes, and I want to do many things that I cannot. I cannot do music or painting, and sometimes even I cannot write because I have writer's block. But you already know that I can write some code, and code can help me, starting from giving me maybe alternatives and some suggestions, but also today it can help me to create media, to generate, to manipulate, to perform with media that otherwise I could not. Code still does not replace not my concepts, not my artistic process. My machine learning, I still write myself, or of course, use open code by others. And maybe most importantly, the poetic or artistic choices are still mine to make. So most of the things we will see today are basically based on this architecture, on this machine, the encoder, decoder, the deep generative neural network, taking in some kind of rich media, which can be image, video, text, and so on, and extracting a latent representation, which hopefully can capture something of the essence or the semantics of this media. And then you can manipulate it or translate it to something else and create on the other side a rich media from the same domain or from a different domain, hopefully after some interesting manipulation. And it was shown that these kinds of latent representation, the deep layer neurons of the neural network can capture very high level concepts. In this example, in a completely unsupervised fashion, Google showed that just from seeing YouTube videos, the concept of a human face or a cat face can be captured just by probably these concepts are important enough in order to characterize YouTube videos. And on the biological side, sometimes you hear about the grandmother neuron or a Jennifer Aniston neuron, and the idea is that the brain decides to make specific neurons. I don't know much about the brain, but expertise on recognizing and specializing in very high level and specific concepts as Jennifer Aniston, for example, not other actresses. So one of the best generative models in the visual domain till this day is begun from a few years ago. And all these images are computer generated, and it can generate an image from one of the 1,000 classes of ImageNet that you probably know about. As an artist, I don't find this very interesting. And on the other hand, this work by a known digital artist, Mario Klingman, he used Big Gun, the same method from the previous slide, to generate these nonsensical images, but he used them to tell some story. And this I found much more interesting. He talked about walking in the desert and meeting some aliens and so on. And I wanted to use this technology to tell my story. But I had a problem. A Big Gun is just a decoder. If you remember the encoder-decoder architecture from before, here we did not get, the encoder was not released, or is not part of the architecture. So essentially, this kind of machine is blind. It can generate images, but starting from some latent code, which I'm not sure what to use. And if I want to generate a specific image, the way to go about it is to solve this problem of inverse rendering. And at the time, I did not find a good solution for BigGun, so I tried to solve it using some kind of evolutionary search. And in these examples, you can see the best solutions at each stage. And in a second, you can see the target image. So I'm using evolutionary search, trying different codes in order to recreate this specific target image. Now, this dog is generated, but this example is based on a photo of a real dog. And you can see the resemblance will not be exact as before, but it's still very good. Now, in ImageNet, you have many dogs. What you don't have in ImageNet is human actresses with angel wings and a blurry photo. And here I try to recreate such an image of a colleague of mine, Savion. And as you will see in a second, the recreation is far from exact in a pixel level, but I think more interestingly, it captures something of the semantics of the person with this puffy white wings. And this semantics was much more interesting to me than the exact recreation. And once I had this technology, I created this interactive installation, WonderGun. So starting from some flickering memory, a real image, and now this blind AI painter tries to recreate something more and more similar to the target image. And I think these attempts create an interesting visual journey. And maybe even something reminiscent of a dreamlike experience. And in this interactive installation, you could press on one of these quadrants, and then it would forget about this initial target and focus on specific area. And maybe like when you dream, you see something, start with something, but see something interesting on the side, and then you go there and develop that concept. So yeah, so this is a work of art, of course. So this was something about image generation, and as you probably know, there was a very important breakthroughs very recently in text generation. So using a language model starting from some textual prompt, we had a GPT-2 at the time, and here this is an abstract for a previous version of this talk, and in bold, so the first part was mine, and in bold was the continuation, and I even got a nice suggestion for a title of this previous talk, the art of deep learning. But now we have GPT-3. Actually, yesterday I got access to the beta, but until then I had to use this AI Dungeon interface. And I don't remember the previous part of the conversation, but I got this very interesting response, a moving one, going like this. So GPT-3 told me, or AI Dungeon, I'm a dragon, I'm a dragon, I'm a dragon, you say to yourself. You're not a dragon, you're a freak, a voice says. You look around and see a large green head with two red eyes, it's the head of a dragon. Who are you, you ask? I'm you, but more badass, he replies. This is stupid, I'm dreaming. Well, wake up then. So I think this is a very nice result. I also think it may teach us something, because this is based on online text that GPT-3 was trained on. It can teach us something about maybe how easy or how pattern-like it is to cause us this emotional response. And people are using GPT-3 also for more exact tasks. For example, writing code from a textual description and creating these JavaScript snippets solving the specific task given in this input text. Okay, and also Google put up very recently Lambda, and in this case it's a conversation with a chatbot that thinks that he is the ex-planet Pluto. So we talked about images and text, and the combination is also very interesting. In late 2016, StackGun was a state-of-the-art, taking a text sentence and creating an image describing this exact text sentence. It was groundbreaking at the time. Specifically, it could do birds and flowers. 1 year later came out Attention Gun, which could also do lasagna and other things. I wanted to see how does it do for my own tasks. And as you can see, the results, the non-cherry-picked results, or maybe even these are somewhat cherry-picked, were interesting, but probably not good enough for industry. But they are good enough for poetry. So in this 30-hour hackathon, together with Eyal Gruss and Vert Haruti, we created this a machine that can listen to live spoken poetry in various languages. It's a shame that you cannot hear this beautiful Persian language. And in real time, create, using Attention Gun, and of course, Google Translate and Google Speech to Text, images describing the spoken poetry, maybe creating a synesthetic experience, transforming words into images, but maybe also creating a more universal experience. Maybe you don't understand Korean, but you could understand that she was speaking about this beautiful flower or some cat-like texture before. And this is what was like the state of the art until very recently. But what happened in the beginning of this year came out a DALL-E from OpenAI, which is an amazing machine. When I saw this, and I'm talking about this stuff for several years now, I said, oh my God, I didn't believe that computers could do something like this. And here it is a one-shot text-to-image generator taking text of a completely contrived concept, a snail made of a harp, and not only understanding and generating relevant visual results, but also combining these concepts into a unified, semantically relevant union of these two concepts into a completely new concept of the snail harp or the harp snail. So this is by OpenAI called DALL-E. And they later also showed that these high-level concepts learned by this model are learned in a multimodal fashion. So if before we spoke about Jennifer Aniston neuron, and here they mentioned maybe the Halle Berry neuron. So for CLIP, which is part of DALL-E, they show that the concept of Spider-Man is learned both for images of Spider-Man and drawings of Spider-Man, and even if there is text about spiders and in the web on the side. Now, unfortunately, OpenAI did not release DALL-E, but on top of DALL-E, there's a small classifier, maybe not small, called CLIP, which they use to rank the visual results. And they did release CLIP, and the community did amazing work taking just the available CLIP and solving the inverse rendering problem, similar to what I explained before for a big gun, to create from these textual descriptions images of these concepts. And I had the luck to be part of these initial efforts. So this is from recent review by Charlie Snell, and you can see on the top, this is the canonical example of the avocado armchair by DALL-E, and these are results from some community released code of taking CLIP to try to recreate the same concepts. And I was able to combine a CLIP with the big gun, and for the first time, I was able to tell the machine to create a rainbow unicorn, a concept that I'm not sure was well defined, and I could never do before, even non-rainbow unicorns. And this shows you the as the process converges, you get something that may look like a rainbow unicorn. And And this is actively developed by, it's mostly on the Twitter community, and people were able to get amazing results. This is an example by Gene Cogan, so showing a banana doing stand-up comedy. So we essentially can still get this amazing ability to combine two unwritten concepts in a way that somehow makes sense. And he also, Gene Cogan also started to play with examples of doing it for a video. And I think very interesting things will happen soon for video. Nowadays, I don't know about too many good results for generating videos, at least not from text. Maybe the best one I've seen and already from some time ago is recreating these Flintstones clips based on some textual description. And for example, Fred wearing a red hat, walking in the living room and so on. But the best models I'm aware of today for generating videos are based on video-to-video translation. And one of the most interesting examples, I think, is the first order motion model and the Avatarify based on it, allowing to do this real-time avatars or real-time facial reenactment. And this guy, in this case, is reenacting his late grandfather. And there are many similar models that came out, for example, allowing to do audio to lip sync and get from a single image or from a video a dubbing of these characters talking. We have examples for full body reenactment. In this case, this is my Kung Fu teacher, and he is reenacting the inventor of this Kung Fu system, who is no longer alive, and unfortunately we don't have any videos of him and very bad images of him. But here for the first time I could see him doing this basic form of Wu Wei Kung Fu. And if you have a better image, so on a very different account, in this case, my teacher is now reenacting me, and probably this is the best instance of me being able to do this Kung Fu form. And new models are coming out like each week, and part of okay, before that, you can think forward about the use cases of these models. So for example, taking a person, this is like a very initial, I think, demo, but taking a person, taking yourself and putting yourself into a game, for example, in a way that is controllable in real time and not just a pre-rendered video. And these are like very recent, and they didn't release the code, and I think they will not, allowing to take a video and edit the text and get not only the new lip sync, but also the relevant head gestures. And maybe if we change the text to something funny, he will smile. And in this case, doing the next week tonight instead of last week tonight, and also getting the relevant body gestures. So all these tools are being released on GitHub, and part of what I'm trying to do is take these kinds of codes and wrap them into accessible GUIs. In this case, I took the first order motion model similar to Avatarify, but allow you to run it in real time if you have good enough internet connection on Google Colab and Google GPUs for free, and having this very rich interface allowing you to change avatars and do a lot of stuff. And actually I did this because I could not find before an option to do live avatars on Google Colab. So all of this is, of course, open source and available. And actually, I was very happy that this organization chose to use these kinds of codes Usually these things go to the, I don't know, to the show business industry or to the porn industry. But actually my first so-called clients was the Israeli education system, using this to teach children about the possibilities and dangers in synthetic media. And to conclude, I started this talk with the quote from David Avidan, and NVIDIA released Maxine, now they call it video-to-video, vid-to-vid cameo, and it came from a very technical reason. They want to allow you to get better bandwidth in Zoom, for example. So they only transmit some kind of low resolution or key points of your face, and they animate it as an avatar on the other side. So this is from a very technical reason. But I think something interesting is maybe happening now. I think we may be moving from an era of communicating and distributing media to an era of communicating and distributing ideas. And you can think of a day when you will communicate the director's instructions or the playwright script, and the media will be generated on the endpoint on the other side. So I hope that the examples I showed you today may convince you that we are in the beginning of this era. And personally, for me, and going back to poetry, very recently for the first time, and I did try for several years, I managed in this project with Eden Azulai, and this was exhibited in Eilat, writing live poetry for 3 months on a 15-meter wall in Hebrew. So this is the first time that I was able to write code that would write a poetry that I thought could be moving and interesting. And don't pay attention to this interactive installation. It wasn't really connected to the wall. Okay, so this is what I wanted to tell you about. Thank you very much.